There is a story that Hans Ørsted was exploring electric circuits, much like this one, with a battery and resistors and wires, and he noticed that a compass he kept on the desk near to him moved each time he switched on the current. And so he was the first person really to establish that there was a link between magnetism and electricity. And we can see this in a second. I'm going to turn on the circuit and the needle twitches. So when I switch on the circuit, you'll see the needle of the compass will twitch. Okay? And when I switch it off again, it will return to normal. So there's clearly a magnetic field around this wire. So this is the wire carrying the current coming through here, and there must be an electric current going on there, and a magnetic field around that current. If we surround the wire with a magnetic field, hopefully we'll be able to reveal the pattern of the magnetic field. So if I switch on now, you can see that the needles are pointing in a circle, and they're all going in a clockwise direction around the wire. So this magnetic field appears to be in a circle around the wire. If I reverse the direction of the current, I can reverse the direction of the field. So when I switch it this way, now rather than going clockwise, it's going anti-clockwise. It is possible to predict the direction of this using what's called the right hand grip rule. So if you hold your hand like so, if your thumb is pointing in the direction of the current, so pointing upwards, your fingers are curled around it in the direction of the field. So at the moment the current is coming up the wire towards the camera, and my fingers are curled around in an anti-clockwise direction, and that's the direction the magnets are pointing. If I reverse the electricity, so the current is going the other way around the circuit, my thumb is now pointing downwards because the current is going down towards the table, and my fingers are curled in the clockwise direction, and that's the direction revealed by the plotting compasses. If we arrange the wire as a coil, so you can see that the wire is coming in and it's curved around and coming out again. So what we have on this side, for example, is the current's coming up. So on this side of the coil, the current's coming up this side and then going down that side. And what that means is that when we switch on, we get that the field is reinforcing. So on this side of the coil, the current is coming up, so it's coming up, so the field's going this way, so coming around in this direction, and on this side the current is going down, so it's reinforcing in this way. So you can see that the field always goes from this side of the coil to that side, because it's going up on this side and down on that side, so they reinforce in the middle. So you can see the plotting compasses pointing through here and like so. If again I reverse the current, we should get the plotting compasses to reverse as well. So the plotting compasses have reversed the other direction now because we've changed the current around. So what we can see here is that by coiling the wire, we've increased the field, doubled the field, because we've got a field due to the current coming up on this side and a field coming down on this side. Now what was realized is that actually you didn't need to stop at one coil. So what we've got now is we've got 4 coils of wire. So we've got 4 lengths of wire that are going up on this side, and the current's coming down on that side, and that will make the field really strong. So we've now made it so from the single coil, when we had a single coil like this, we've now got the sum total of all of these coils, so the field is going to be much stronger. And if I switch on, then the needles very quickly rotate around. So if I use my right hand grip rule, so the field is going this way around, so it's going clockwise here, and it's going anti-clockwise here, like so. So I can work out from there the direction of the current, because the field's going around clockwise. So on this side the current's going down. On this side of the coil the current's going down, and on this side the current must be coming up because my thumb's pointing upwards and the field is going in an anti-clockwise direction. Again, if I just move these out of the way, the field always comes through this direction. So the field is coming through from both coils through the center of the coils. If I reverse it, again I can switch it around. So let's put these back. If I switch it back, then it will go in the other direction. So by reversing the current, I reverse the field. If I coil the wire up like this, I'm creating myself an electromagnet. And all these coils are creating a field, so each coil creates its field, and that will create quite a strong field through the center. And if we're coiling wire like this to make an electromagnet, we actually call this a solenoid. So this is a solenoid. And if I switch on the current through the coils, you can see that the field is going straight through the middle of the coils, and then it's coming out at the end. So it's coming in from this side and out from this side, and this is very similar to the behavior of a bar magnet. So the field lines are coming out here. One thing to realize is that inside the coil we've got a very uniform field, so we've got a very steady field inside this coil, and then outside it happens very much like a bar magnet, is that the field is going around like so. So the field lines are coming in from this end, and they're coming out from that end. And of course that would allow you then to work out that this is acting the same as a bar magnet, with this being the north end of the magnet and this being the south end, because the field lines are going from north to south. If I place this here, hopefully you'll see that the plotting compass is going parallel with the field lines, and the same on this side, so it's following the field lines across like so. So very similar to a plotting compass, you can see that the field is coming out, coming around like so, and then coming back. But remember, in the middle it is a uniform field.